What is Spark? Spark is an increasingly popular alternative to replace MapReduce. It's a performant execution engine, but it still uses Hadoop HDFS storage engine for large data sets. And Spark provides programmers with an application program interface centered on a data structure called Resilient Distributed Dataset, that is RDD. The system aims to provide fast computations, fast writes, and highly interactive queries. Spark significantly outperforms Hadoop MapReduce for certain problem classes. It provides simply Ruby-like interpreter interface. And Spark beats Hadoop by providing primitives for in-memory cluster computing. It avoids the input-output bottleneck between the individual jobs of an alternative MapReduce workflow, and it repeatedly performs computations on the same working set. And the Spark make use of the Scala language, and it allows distributed data sets to be manipulated like local collections. It provides fast development and testing through its interactive interpreter. And Spark was developed to support interactive data mining. The system also puts applicability for many general computing problems. The site includes example programs for file search, in-memory search, estimating PI. Spark is well suited for most dataset transformation operations and computations. And we will look what is the Spark architecture. Spark architecture means from architecture perspective, Apache Spark is based on two key concepts, that is RDD and directed acyclic graph. With regards to data sets, Spark supports two types of RDDs: parallelized collections that are based on existing Scala collections, and Hadoop datasets that are created from the files stored on HDFS. Resilient distributed dataset is an important topic, and RDD supports two kinds of operations, that is transformation and actions. What do you mean by transformation? Transformation creates new datasets from the input, whereas actions return a value after executing calculations on the dataset. And there is a DAG engine. What is DAG engine? So, DAG engine helps to eliminate the MapReduce multi-stage execution model, and it offers significant performance improvements. So, DAG engines is two types, direct and acyclic. Transformation is an action which transitions data partitions of state from A to B. That is a direct transformation. And acyclic means transformation cannot return to the older partition. The DAG is a sequence of computations performed on data where each node is an RDD partition and edge is a transformation on top of data. And the DAG eliminates MapReduce multi-stage execution model. And the Spark is built to run on top of Apache Mesos cluster manager, and this allows Spark to operate on a cluster side by side with Hadoop, message passing interface, hyper table, and other applications. And Spark allows an organization to develop hybrid workflows that can benefit from both the data flow models with the cost, management, and interoperability concerns that would arise from using two independent clusters. Another is spark streaming. Spark streaming. Uh, s- so there is two types of spark streaming is there. One is stateful stream processing and another is assisting streaming systems. So first we look what is stateful stream processing. So in this figure you can see the figure of stateful stream processing. Traditional streaming systems have a event-driven record at a time processing model, and each node has a mutable state. For each record, update state and send new records. State is lost if node dies. Making stateful stream processing be fault tolerant is challenging. Then existing streaming systems is there. There is two types, Storm and Trident. What do you mean by Storm? Storm means it replaces record if node processes it by a node and process each record at least once. May update mutable state twice. Mutable state can be lost due to failure. These are the states of storm. There is trident is there. Trident means use transactions to update state. It processes each record exactly once and per state transaction updates slow. Most traditional streaming systems involve an update and pass. These systems can handle fault tolerance by replication. Then another is discretized stream processing. What do you mean by discretized stream processing? It's run a streaming computation as a series of very small deterministic batch jobs. It chop up the live stream into batches of some seconds. Then Spark treats each batch of data as RDDs and process them using RDD operations. Finally, the processed results of the RDD operations are returned in batches. It runs a streaming computation as a series of very small deterministic batch jobs. Batch sizes as low as half second, latency approximately 1 second. It's a potential for combining batch processing and streaming processing in the same system. With these limitations in mind, Spark Streaming team looked to batch systems for inspiration of how to improve scaling and noted that batch systems always divide processing into deterministic sets that can be easily replayed. It failed or those stacks are rerun in parallel on other nodes. Lower batch sizes have much lower latency. This led to the idea of using the same recovery mechanism at a much smaller time scale. And Spark becomes an ideal platform to build on because it is in memory storage and optimization for iterative transformation on working sets. And another is about Spark streaming operatives. There are two types of Spark streaming operators. One is transformation operator and other is output operator. Transformation operator, it produces a new data stream from one or more parent systems. It can be either stateless or stateful. Then another is output operators, which let the program write data to external systems. Spark streaming supports to the same stateless transformation, and basic real-time streaming is a useful tool in itself. In order to support windowing and aggregation, Spark streaming development has created two evaluation models. This is all about Spark.